Okay, good afternoon. There is a very short part of the lesson important. Might be, I don't think you have seen this before. It's a good example of how we can use ideas to prove things in geometry. So that is called the angle. Okay, I should have put it on there. Angle-Bisector Theorem. Okay, so what is the content? The content is very simple. This tells you that if you have a triangle, ABC, and you, for example, draw one of the angle bisectors. Which one doesn't matter. So, for example, let us consider this one. Thank you. Cool. So I divide this angle, for example, into two equal pieces, and then I draw this angle bisector. Yes. So this angle bisector. So let me write. This angle is equal to that angle. Let me call this one A1, let me call this one A2. So my assumption is that A1 is equal to A2. Okay, then we want to show that when this line goes and intersects this line, and then the ratio of these two, BD over BC, is exactly equal to the ratio of the corresponding sides. So it means that if you measure this length and that length and then divide them, you make up a fraction. This fraction turns out to be always equal to the fraction of AB over AC. Of course, this is what we want to prove. This is what we have. Yes? So what we do, there are different proofs for some theorems actually. That is also different proofs for this one as well. But let me just try to mention the one in the book. So the one in the book is just telling you this. You take this point, which is outside this angle bisector, and draw a line parallel to this one, so that it will go and intersect the extension of this side at some point. Okay, so that's the idea. Let me see if I can use this big ruler to make that a little bit nicer. So you have this. I'm trying to draw this parallel to that. So I will take this point and I draw this line parallel to the angle bisector. Yeah, I think that's enough. So that it will go and intersect with the extension of this side, okay? So this will actually go and intersect that, okay? Something like this. But you need to, because this is something that I add to the picture, so I have to explain that. So I would say that, let me call this point E. We draw from B we draw a line or a ray parallel to AD such that it intersects the extension of CA at a point P. At a point E, sorry. Okay, so I ask you, I want you to help me to see why this is true. My first claim is that this triangle that I make up here is an isosceles triangle. But why is that? So the claim is, we show that the triangle AB E is isosceles. Okay, why do you think this is correct? Do you see any reason why it should be isosceles? Of course, if it is going to be isosceles, I think my picture is good enough to guess that AB should be equal to AE, yes? If this is going to be the case. Not AE and EB, of course. It doesn't fit. So my picture is good enough to understand that if it is going to be isosceles, your hunch should be on this, that AE and AB are equal. But can you tell me why AE and AB are equal? Because the only piece of information that I have is about angles. So to prove that this is an isosceles triangle, it is better to concentrate on two angles, yes? This angle here and that angle there. If I can show that these two angles are equal, then this automatically tells me that AB and AE are equal. Yes? But why these two angles are equal, so let me call them B1. And this E is good. Okay, I want to show that B1 and E are equal in size. Do you have any idea why this is true? Yes?
Oh, wait. But did we just say that? No, we didn't.
No, the only thing that we know is two pieces of information. Right now, I know that I drew this parallel to that one. This I know because I did it myself. And from the beginning, I know that the sizes of these two angles are the same.
Can say that the angle of E is the same as the two A1 and A2?
It is equal to A2. But of course, automatically it becomes equal to A1.
Yeah.
Yes?
No, it's equal to A1. Like, or if it's...
No.
If we didn't know that they were equal to each other.
Yeah. If you didn't know, it should be equal to A2, not A1. Yes?
We know that A1 is a vertical line with B.
Yes?
Because they have...
No, they are not vertical. They are not vertical. You mean these two?
Yeah.
So I don't understand exactly what you mean, because vertical angles are these two angles having the same vertex. But this vertex of this angle is B, the vertex of that angle is A. So this is actually, I think this you need to say is this is the Z shape or N shape or whatever you want to call it, yes?
That was right. Yeah.
Because this, okay, so now I understand, this is not vertical, okay? These two lines are parallel and this line is transversal. And when they are transversal, it means that these two angles are the same. Yes, so you have to write this down. So we say that AD is parallel to BE and, okay, you don't need to write and AB is transversal. So because of these two assumptions, I can conclude that angle A1 is equal to angle B1. This is something that we can conclude from this one. But now what Rasmus said is also based on the paralleleness of these two, but we have to change the transversal. So I will change my transversal to E. Then this angle and that angle become corresponding angles. Yes? Then I would say that, okay, again the same story. AB is parallel to BE, but I change the transversal from AB to CE, for example. CE is transversal. So I can conclude that angle E is equal to angle A2. Okay? But since angle A1 is equal to angle A2, we have angle B1 equals to angle E. Yes, is that understandable? Because E is equal to A2, B1 is equal to A1, but A1 and A2 are equal, so they have to be equal themselves. And then this means that these two angles are the same, so this means that this triangle is an isosceles triangle, yes? This means that the triangle ABE is isosceles, yes? So when it is isosceles, it means that I can the length of AB and the length of AE are the same. This means that AB is equal to AE. Okay, so that is something we need. So let me call it number 1. So now we understood that. Before we didn't know, but now we know that this length and that length are equal. Okay, but I hope that you haven't lost the logic. We want to show something about the ratio of the fractions, but how do you think this will help me to finally prove the question mark, the validity of the question mark? So look, we want to have BD divided by DC. We want to prove that this is equal to AB over AC. Yes?
I think we can, because AB is equal to AE, we can just forget about AB and
Yes.
consider the triangle, the lines AC and BC.
Mm-hmm.
And now I don't remember, wait, what was the thing we said? It was...
Top triangle or something like that, but of course it is not top triangle, it is now right triangle, yes? So what Rasmus is proposing is that you can momentarily forget about this, okay? But then what happens? So let me just clean it. If I just clean it, what happens? You see that you have a big triangle, and this line is parallel to that one. So do you remember we can write something? We can write CA over AE is equal to CD over DB. Yes, do you remember? Okay, so let me put this back up now. Okay, so oops, I think it's better. Back again. So this is the theorem that we want to use, okay? So now we can say that, okay, AD is parallel, but of course when you write it in this form, the name is a good name. You say top triangle theorem, but there is no reason that it should be only top triangle theorem. We can have these two lines parallel, yes? Then you can say this one to this one is equal to this one to that one is equal to this one to that one, or you can say that, okay, this one to this is equal to this one to this. Okay, I mean that you can see it from different views. So, but it is common to call it top triangle theorem, but there is nothing specific about being top triangle, yes? Okay, so I hope that you understand what is going on. If not, please let me know so that I can explain more, so that I can just immediately get rid of this in my head, then I will have that formula. So I would say that AD is, so let me write the name of the triangle as well. So in the big triangle, in the triangle BEC, I can say that AD is parallel to BE. Then I can, I don't know, based on top triangle theorem, what can I conclude? I can conclude CA over AE is equal to CD over DB. Yes? Okay? But it is, I think it's very clear for you now that what I'm going to do, I can use number 1, because AB is equal to AB, I can write AB instead. And you know that there is no difference between CA or AC. So if you don't mind, let me write it AC. And in the denominator, I would write AB. On the right-hand side, I don't need any changes actually, but instead of writing CD, let me write BC. There is no difference, and DB is B. Okay, but this is not exactly what I have written here, but I hope that you agree with me that is actually clear, that AC over AB is equal to DC over BD. So if I swap these two, to keep the equality the same, I have to swap these two as well, okay? So this means AB over AC is equal to BD over DC, and that will be the end of it. Yes? So I would say that this is a little bit serious theorem, so you have to be a little bit native in understanding how to do this. But the result is something that, of course, is given in the formula sheet, but if you are interested in solving harder problems, it is better to remember this. It's a very important rule of angle bisector only. So it divides the opposite side to the ratio of the corresponding sides. Okay, so let me solve an example for you here. Let me just pick the, so if you want it, I think, let us just try to practice this with a little bit simpler way of writing. So if I have this ABC and I draw this angle bisector, okay, usually in geometry I told you that the length of the opposite side to C is denoted by little c, and this one is little b, okay? And let me call this one x, let me call this one y, this is d, so this angle is alpha, this angle is also alpha. So I think it's good to remember this shape. If you want to write, you can start writing x over y. But if you chose to write x first and then y second, for these two sides you have to respect the order. Here you don't need to respect the order. You can choose whatever you like. But when you write the left one, then you have to respect the order for the right one. So if you write x on top, the one which is close to x, c, should be written on top, and the one close to y, which is b, should be written here. Okay? That is one way of viewing this. So let me just draw another picture for you here. So if I do this, this is ABC, and then this time let me divide this angle to two sections, to two equal parts. So let me call this one beta, this one also beta. And then let me call this one, this time x, this time this one y. And then the length of the opposite side to capital B is little b, and this one is little a. Okay, if I want to repeat that theorem in this setup, so what should I write? For example, again, let me choose x over y. It is up to you to choose which one, but let me choose x over y. If I choose x over y, and if these two angles are the same, then what should I write on the right?
B over A.
B over A. This is not arbitrary. You have to write B over A.
Let's go.
Okay? And then let me also write this one to make sure that it's understandable. So A, B, C. I don't know. For example, let us divide these to two equal pieces, gamma and gamma. And then let me call this one x, this one y, and then this is little c, this is little a. Again, I want to write x over y. When I write x over y, here I have to write c over a.
I'll do that.
So be careful, this is not valid if this is just a random line. It has to be the angle bisector, yes? Median does not work, height does not work, only and only angle bisector. Okay, so let me solve one example which is in the book and then try to pick one or two examples from the exercises. Okay, so this is the example given in your book. But of course, it's really simple. So you have this shape. It is mentioned that they haven't written something, but they have put these signs. So it means that this is telling you that these two angles are the same. And they have written here x, they have written here y, and from here to here is 12, comma 0. Everything is in centimeters. And this is 6, comma 0, and this is 9, comma 0. Okay, and you are supposed to find the values of x and y, which of course I think is extremely simple, isn't it? Because those angles are this angle is bisected by this line, so I can use Angle-Bisector Theorem. If I want to do that, what can I write? I can write x over y is equal to 6, comma 0 over 9, comma 0. Yes? Okay, but I cannot immediately find x and y because I have two unknowns, but let me simplify this. I would write x over y. I divide everything by 3, so it becomes 2 over 3. So that is one relation, but from this one, be careful. You are not allowed to conclude x is 2, y is 3. No, because there are two unknowns you have to solve. But of course, there is another extra piece of information given to you in the problem, and that is you see that when they say this is 12, it is just telling you that x plus y is what? 12, yes? Now you have to set up a system of equations in which x plus y equals to 12 is one of the equations, and x over y is 2/3 is another one. And now you have two equations in two unknowns. In principle, we should be able to solve for x and y and find the values. Okay, I don't know which method you prefer to do. For example, let me just multiply, because you know that the best method for solving systems is method of substitution. So it means that I need to find one variable in terms of the other and put this into the other equation. So for that one, I just multiply everything by y, by this plan in mind, yes? So it becomes 2/3 times y. And then I go here and instead put it here, okay? Instead of x, I can put 2/3 of the y. This becomes 2/3 of y plus y is equal to 12. But this is not a big problem, yes? Because that is just one equation with one unknown. But because I have fraction, I prefer to get rid of the fraction by multiplying everything by 3. When I multiply this by 3, it becomes 2y. The next one becomes 3y. And the next one becomes 36. And then when you add them, it becomes 5y is equal to 36. And then if you want to find y becomes 36 divided by 5. If you want, we can, in this case, write it in fraction form, 7, comma 2, yes? But you have to write the units, so it is centimeters. Yes. And then when I when I got y, I can put it back here and find x, for example. yes? Or I can even put it here, it doesn't matter. But let me put it here, okay? So y is equal to, x is equal to 12 minus y. But what is my y? My y is 7, 2. It becomes 4, 8, yes? Centimeters. So these are my answers. So you see that problem was actually very simple. Okay, so let me see. Are there some level 2 problems here? What they are talking about? So I see some questions there, but I don't think all of them are related to this theorem. That is a little bit strange because usually the exercises should be around that theorem. So let me solve this one to see. I don't know. I don't think this theorem is useful at all for this problem, which is in this section. We can see. So this is in my hard copy of the book. It is problem 5052. I don't know in electronic version what is that, but they have given you a right angle triangle. This angle is 90, and then they have drawn two angle bisectors, one for this one, right, something like that. This is an angle bisector here. There is also another angle bisector of this one. Yes? So this, let me call this one, they haven't called this, but I am calling it myself. Alpha, alpha, they are the same. Beta, beta, they are also the same. But they are not asking something related to the length of something. They are asking to calculate this acute angle, which they call it W. So the question is that can we somehow, I don't know if I understand it correctly. Yeah, so we are supposed, I don't know what they mean, because determine the angle W between these angle bisectors. I don't know, do you think it could be a specific number? Anyway, let us think about it. So, I don't know if they want us to find a relation or we really are able to calculate the number of W. I don't know, we have to think. Okay, so do you have any idea at least what to do? Now that I think, yes, we can find an angle, a number. I can pause recording if you want to think more. Okay, no progress. So let me ask you, you answer my question. Can you tell me what is 2 alpha plus 2 beta? This you can immediately answer. Of course, you need to understand how to look at the picture in the correct way. Then 2 alpha plus 2 beta is 90. Yes, because in the bigger triangle, 2 alpha is this angle, 2 beta is this angle, so this should be 90. So this means that if I divide everything by 2, it becomes 45 degrees. But my claim is that alpha plus beta is W. Yes? Why is that? Why alpha plus beta is W? Yes?
Because it's the
exterior angle. Yes? Because you see here, if you concentrate on this triangle, yes, this W is not inside angle, yes, it is not interior angle, it is exterior angle. But I told you it's an extremely important theorem to remember that if you have an exterior angle, that exterior angle is equal to the sum of two interior angles which are not adjacent to it. So it means that what is that? It's alpha plus beta. This means that this is nothing except W. So W, yes, it's always 45 degrees. Is that understandable? So it means that it doesn't matter how big or how small your right angle triangle is. This angle that you make between the angle bisectors is always and always 45 degrees. Of course, you have to explain that because alpha gamma is the exterior angle of this triangle, it is equal to alpha plus beta. So that's you see, it is not related to that problem. Let me see if I can find something that is related to that problem. If I understand the translation correctly, so in a right angle triangle, the bisector of the right angle divides the hypotenuse to these. Okay, so let me just, it is easy. So I don't know, for example, let me draw it in that way again. So I have a right angle triangle in this way. This is telling you that the angle bisector of the 90-degree angle here, this means that I divide it into 245 degrees, okay? It will go and intersect the hypotenuse. One of them is 7 centimeters and the other one is 9 centimeters, okay? We are supposed to find the length of the sides. For example, let me call this one X, I want it. Let me call this Y, I want it. So, but remember, this is the angle bisector. So it is 90, so it means it is 45, it is 45. I am adding these things. There are no pictures for this problem. You need to read the text and draw the graph, the figure yourself. Again, I think this is related to what we learned today, the angle bisector. But this is something related to what we learned before. Okay, so can you help me to solve that? If you want, I can name it. So if you want, so this, let me call it ABC, and then this point is D. So this part is 7, this part is 9. X and Y are wanted. Yes?
We can say that 7 over 9 is equal to X over Y.
Yes, that is probably clear that we have to use it somehow. It's a very good relation because I have two unknowns, so I need two equations. But one equation is just we learned today. Yeah? So this becomes X over Y is equal to 7 over 9. So that is one relation. Okay?
And then we can also say X squared plus Y squared equals to 16.
The square, because that's a Pythagoras theorem. Yes? So that's also clear. This means that X squared plus Y squared, so the hypotenuse is 16 centimeters. Yeah, so this becomes X squared plus Y squared is 16 to power 2, which is 256. Yes? Again, so the problem from geometrical point of view is easy. It is algebraically a little bit not standard, but you already practice, I hope, in the exercises. This is 256. And then I have X over Y equals to 7 over 9. So we change, so now this is not anymore a geometry problem, it's an algebra problem. So you can just forget about geometry and try to solve this algebraically. And then I told you that the best method for solving any type of system is method of substitution. So for example, here again I use the same trick. I multiply everything by y, so x becomes 7 over 9 times y, and then I put it here. Yes? What happens? This becomes 7 over 9 to the power times y to the power of 2 instead of x. And then instead of y, I just copy and paste y squared is equal to 256. And then you have to be careful to solve this without mistakes, which is, I think, very simple. Might be the numbers are bad, then we use our calculator if necessary. So, okay, so I raise this one to power 2, which is 49 over 81 y squared plus another y squared is equal to 156. Okay, at the end I think I have to multiply, but I try to avoid. So let's see. If I multiply by 81, because I want to get rid of the fraction, this becomes 49y squared plus 81y squared. For the time being, 256 times 81. So let us keep it like this. And then at the end we can put this in the calculator if we need. I think it's inevitable. We have to put it in the calculator. So because what is the answer here? 49y squared plus this one is 130y squared, yes? Is equal to 256 times 81 divided, no, not divided, the division is the next step. I want to make y alone, so I divide, and unfortunately nothing can be simplified. Yes, because this is 16 to power 2, this is 9 to power 2, but this is just 10 times 30. Yeah, I can't divide by 2, but that doesn't help that much. Yes. Anyway, so y is equal to, in principle I have to put plus or minus, but in this case y is representing a length, so it cannot be plus or minus, it is always positive. And then I take the square root of 256 times 81 divided by 130 centimeters. But for the numerator, square root of 256 is 16, square root of this one is 9, divided by square root of 130, which is 144 divided by square root of 130 centimeters. If the exact value is wanted, which is I think the only thing I ask you usually, we can keep it exactly like this. But if you want the approximate value, and by the way, when I was a little bit careless writing, they have mentioned 7,20, so they want to up to 3 significant figures, yes. So can you just do that to see how it goes? So we want to keep 3 significant figures as well. It should be around 13 or something, yes or no? What's the answer? No one got it? Yes. 144 divided by square root of 130. Because this is less than 12. So I guess that it should be around 13 or something.
12.63.
Pardon?
12.63 is what I got.
Okay, 12.63.
63.
So I want to keep 3 decimal significant figures, so I stopped there. And anyway, when you found this one, I put it back here. I think it would be harder if I want to put it back here. I put it here, and I will find x. So x becomes 7 over 9, and please also do that for me, thank you, times this one, comma 6. What happens here? You have to multiply by 7 and divide by 9. What is that?
9.8.
9.8. What is the next one?
That's it. That's what
Complete?
Yeah.
Okay.
Let me double check. 9 times.
No, 7 times. 7 times 12, comma 6.
That's right.
Then divide by 9.
9.8.
Okay, so if that's 9.8, I keep also a 0 there. Okay, so let me, by the way, double check that if I have done everything right. 50-50. That was the problem. Yes, 9.8, 12.6. So we did it right. Okay, so I will stop here because the next lesson is quite long and very important. I want to cover it. I think Monday and Tuesday we will be done, and then you will get time to practice to have the test on week 21. Okay? Because analytic geometry I have already covered, and we have already done the exam for it. So that would be this circle, and the angles in the circle would be the last section of this particular study. Any questions? Thank you. I will start updating the Google Classroom if you want to practice a little bit.